Welcome to topic number 29 in Richard James Mathematics Resources. This one is entitled Solution of Quadratic Inequalities. Most times, this topic is seen as just another means for mathematicians to get at the ordinary people. The fact is, mathematicians are not egotistical. They just develop methods that are vital to our understanding and survival in a highly mathematical world. Solution of quadratic inequalities should not be viewed as a topic in isolation, but an introductory step in figuring out conditions for any variable to be above or below a particular level. If inflation rate is dependent on the interest rate offered by banks in a parabolic relationship, the Minister of Finance may look at a graph and determine the range of values of the interest rate that will cause the rate of inflation to be below or above a particular level. Solving quadratic inequalities is just a stepping stone to solving similar problems in which the dependency of one variable upon another may be defined by a curve. I have made presentations to CAPE students and students reading for associate degrees. The principles used to solve inequalities and sketch curves are just extensions of the concepts that will be presented in the next few seconds. It is very important that students are able to apply the concept in preparation for CSEC exams, make use of them when required at a higher level, and ultimately in the real world when systems that control lives, population, interest rates, and poverty are dependent on them. One of the most basic of quadratic inequalities is the one that we have right there. X squared minus 25 is less than or equal to 0. But what does this mean? The expression is a function of x. Therefore, we are talking about a solution of the equation that satisfies f of x is less than or equal to 0. Remember also that f of x occupies the y-axis. So, this axis may be labeled y or f of x. The inequality is similar to writing f of x is less than or equal to 0, or y is less than or equal to 0. We are therefore attempting to establish where on the curve y is less than or equal to 0, and that is of course according to the values on the y-axis. So we are trying to determine where the value of y is less than or equal to 0. But the solution is required to be in terms of x. So the solution is required to be in terms of x. Just like the interest rate and the rate of inflation. The rate of inflation is dependent on the interest rate. So if there is something happening to the rate of inflation, we see what happens to the interest rate. So our investigation should be taking into account what is happening to the interest rate that is offered by banks. In essence, we are looking at what is happening to y, which is of course our rate of inflation. But we are describing the causes in terms of x, which is of course the interest rate that is going to be offered by the banks. That is how it is in the real world. The rate of inflation is behaving in all types of unfavorable ways, but it is not performing of its own accord. The culprit is the interest rate offered by banks, on which the rate of inflation depends. We therefore supply an answer in terms of the interest rate. So, we are trying to figure out what is happening to y or f of x, but we are supplying an answer in terms of x. So we have some points to consider, and we are continuing with them. Remember that we are attempting to determine where y is less than or equal to 0. And this is given in terms of x. Let us begin to focus on x, while keeping in the back of our minds that we are attempting to describe the behavior of y. In order to determine the conditions, which is dependent on x, the x conditions for y is less than or equal to 0, let us first determine the conditions where y is equal to 0. So then, if we are going to determine where y is less than or equal to 0, we will begin at the point where y is equal to 0. Where in the coordinate system is y equal to 0? Another question may be then, which line has equation y is equal to 0? That is our line, the x-axis, of course. So y is equal to 0 is the equation of the x-axis. So then, if we are going to ask where in the coordinate system is y equal to 0, y is equal to 0 at every single point on the x-axis. So y is equal to x squared minus 3x minus 10, or we may say f of x is equal to x squared minus 3x minus 10. And of course, because y is supposed to be equal to 0, then we know we are equating x squared minus 3x minus 10 to 0. So our equation is now x squared minus 3x minus 10 is equal to 0. And we have factorized this. As a matter of fact, we are solving a quadratic equation by factorization. And this brings into account two previous topics that we have studied already. 1, solution of quadratic equation, and 2, factorization. Remember, factorization is number 4, and solution of quadratic equation is number 7, and they are both in volume 1 algebra. X is therefore equal to 5 or negative 2. So we're not going to the detail, or some people might say the nitty-gritty of the solution of quadratic equations, because we have done a wonderful job in the previous topics. So let us place the two x values on the axis. We have 1 right there, negative 2 to the left. Of course, those numbers that are smaller are placed to the left. So negative numbers are placed to the left of positive numbers. The convention must be maintained when solving quadratic inequalities. That is, the convention of always putting the negative towards the left. So the sketch required in this subtopic makes use of the x-intercepts and the fact that the x squared coefficient is positive. The sketch may be completed by a U-shaped curve that crosses the x-axis at x is equal to 5 and x is equal to negative 2. Do not forget that prior to this we have done an entire topic in the sketching of parabolas. And some students and teachers pronounce the word parabolas, but my ancient mathematics teacher pronounced it parabolas. Right, and I'm trying to pronounce it that way also. So we have that U-shaped curve that passes through negative 2 and 5 on the x-axis. We have located the points where y is equal to 0. They are represented by the x-intercepts of the curve. But what does the inequality say? The inequality says what? Right there. Less than or equal to 0. That is what the inequality says. Less than or equal to 0. So what is less than or equal to 0? less than or equal to 0. But what does this mean? Since y is equal to 0 is located on the x-axis, we need the points where the curve is below the x-axis. So then, y is equal to 0. Remember that we are solving the inequality for y. Y, or f of x, or the expression, is less than or equal to 0. Therefore, when we say y is less than or equal to 0, we are talking about the x-axis as our line of reference. Therefore, y is equal to 0 on the x-axis. The expression here is equal to 0 on the x-axis. F of x is equal to 0 on the x-axis. We are talking now about less than or equal to 0. Therefore, we are talking about the portion of the curve that is below the x-axis. So what does this mean? Since y is equal to 0 is located on the x-axis, we need the points where the curve is below the x-axis. So what do we mean? This region here, where the curve is below the x-axis. That's what we are solving for. To understand what happens for all values of y less than or equal to 0, we will begin where y is equal to 0 and take the intercepts one at a time, beginning with x is equal to negative 2. So, what's that? We have our points right here. It looks like one, but we have two of them. We are going to go down along the curve here, right? We require y to be less than or equal to 0. So we are starting at the point where it is equal to 0, and we are going where y is less than 0 along this curve. So y is equal to 0 on the axis, y is less than 0 below the x-axis. So we are going to continue down below the x-axis and see what happens. So we are going to continue below the x-axis and see what happens. While we are going down along the curve here, what is happening to the point that is on the x-axis? So let us see what happens to the value of x as the value of y goes less than 0. That is, the curve goes below the x-axis, beginning at x is equal to negative 2. So let's see what happens. Notice that while this is going down like this, the point on the x-axis is going to our right. So let's see that again. As we go down, we are going to, so we are starting here, and the motion is in this direction. Right. As one point goes below the y-axis, which is the point that is going on the curve, that is going for what? Y is less than or equal to 0. The other point goes to the right along the x-axis. So while the curve is going below, we are trying to describe that in terms of x, and that is what we are going to do. We are going to describe what is happening to the value of y in terms of x. So as y is getting below the axis along the curve, we notice that the x value, we begin at negative 2 and we are moving to our right. So as one point goes below the y-axis along the curve, the other point goes to the right along the x-axis. This shows that beginning at x is equal to negative 2, the values of x are increasing all the time, because value that goes in this direction, we are getting larger and larger, so we are increasing all the time. The values are therefore greater than or equal to negative 2, and we may write that in the form of a set. This is represented by the set of x such that x is greater than or equal to negative 2. And there we have it in set notation. The set of x such that x is greater than or equal to negative 2. So let us go to the next x-intercept, which is 5, in order to complete our analysis of the condition required for y to be less than or equal to 0. And that condition is described in terms of x. So y less than or equal to 0, we'll go from here and we'll go down, where y is going down less than 0, and see what is happening to the value of x in the meantime. Next, let us see what happens to the value of x as the value of y goes less than 0. That is, the curve goes below the x-axis beginning at x is equal to 5. So while we start right here, look what happens. While we are going down here below the axis, so the y value is getting less all the time, the value of x is going in what direction? We are starting here along the x-axis and we are going in that direction. We are getting less each time. As one point goes below the y-axis along the curve, the other point goes to the left along the x-axis. This shows that beginning at x is equal to 5, the values of x are decreasing all the time. Therefore, the values are less than or equal to 5. This is represented by the set of x such that x is less than or equal to 5. So we have one here, and we place the other one at the top, as you can see, like that. Now, we have two sets. Our answer yields two sets, and we need to determine if the sets are to be intersected or united in our final statement of the answer. So that is what we are going to do. Check to see if it is going to be a union that we put here or an intersection. What would happen if we were to continue moving along the curve beginning at x is equal to 5? What will happen if we continue to move along the curve? Although all of the values are less than 5 according to the requirement laid out in the set, there comes a time when the curve goes above the x-axis. This violates the requirement of the inequality that what? Should not go above the x-axis. See there? The curve goes above the x-axis eventually. But what should happen? The requirement of the inequality that what? Y is less than or equal to 0. But let's see what happens here. Notice we continue, and if we going down still, the curve is going to eventually go above the x-axis. So look again. While we are going down here, we are continuing until we eventually go above the x-axis. But that violates the requirements of the inequality that we have right here that says it should be less than or equal to 0. But notice what happens when we just began. At the beginning, we are going in this direction as the curve is going below the x-axis, which is desirable, which is what we really want. Although the values of x that are here are also less than 5, as required here, x is less than or equal to 5. Although these values are less than 5, we realize that there comes a time when the curve moves above the x-axis. So it moves like that. Let's see again. Right. Okay, good. So then the condition does not hold for all values of x that are less than or equal to 5. And if we do the same from the other end, and let's see what happens. If we were to continue moving along the curve beginning at x is equal to -2, let us go to the next x-intercept, which is -2, in order to complete our analysis of the condition required for y to be less than or equal to 0. So let's see. Here, right. So, although this value of x is desirable in this region, x is greater than or equal to 2, which is what we want, it violates the condition when we get to this point, because at this point the curve is above the x-axis. So what is the condition overall then? In what portion of the diagram are the values of x that satisfy the inequality? Surely the region between -2 and 5, because in this region right here the curve is below the x-axis, which is what is desirable. But when we get here, that's not going to be correct. And when we go over on this side, the curve is also above the x-axis. So we do not want that. So we have to write our sets in such a way that it caters for only this region. And notice that this region is going to be the intersection of the two sets. So that is our region, the region from here to here and inward. The region is satisfied by the elements that the two sets have in common. The region is satisfied by the elements that the two sets have in common. In set theory, this is called the intersection of the two sets. So, our answer will make use of the intersection of the two sets. And realize here what is happening. We have the points coming together. The points are coming together beginning at the two extreme values, -2 and 5, and whenever we find that the points are traveling towards each other in that manner, the sign to be used between the two sets is always intersection. The solution may be stated as the set of x such that x is greater than or equal to -2 intersection the set of x such that x is less than or equal to 5. Since x is between -2 and 5, we may write the set of x such that -2 is less than or equal to x is less than or equal to 5. And we are accustomed to seeing this kind of a setup. It is present in many of the previous topics. One of the topics that we have seen this inequality in is functions part 1, when we are drawing quadratic graphs, and we'll no doubt see this again when we take a look at linear programming. Therefore, whenever the points are moving in such a way that the x values are getting closer and closer together, it is intersection, and this is the format in which the answer is going to be given. Now we have another one. We are attempting to determine where y is greater than 0, and this is given in terms of x. So this expression is a function of x, so we are saying f of x is greater than 0 or y is greater than 0, but the answer will be given in terms of x. So let us begin where y is equal to 0 by solving the equation. So 6x squared plus 10x minus 3x minus 5 is equal to 0. So we are taking steps to factorize this trinomial that we have right here in order that we might get our two factors that we need to finish the solution of the quadratic equation. And of course, we're not going to visit the details of that right now. Good. We are actually saying what two numbers multiply to give 6 times -5, that's -30. The two numbers multiply to give -30 and they add to give a +7. The two numbers are actually +10 and -3. Now we factorize 2 by 2 as usual, taking 2x as a common factor. Here we do not have any blatant common factor, so we take a -1 as our common factor. Of course, in the end we'll have to say negative into negative is positive. Of course, the common factor is 3x plus 5 that we have in both these brackets, and the remaining factor will be 2x minus 1. When we solve these, we get 3x plus 5 is equal to 0, so x is equal to negative 5 over 3. And 2x minus 1 is equal to 0, so x is equal to a half. So let us place the two x values on the x-axis right there. All we need to know is that the curve is U-shaped. Of course, it has to be U-shaped. The x squared coefficient is positive, and the curve will pass through the x-intercept given on the axis. There we have it. We are attempting to determine where y is greater than 0, and this is given in terms of x. So begin at x is equal to negative 5 over 3 and traverse the curve in the region where y is greater than 0. So we are going to start right here, and we are going to go in the direction where y is greater than 0. Where y is greater than 0? Above the x-axis. So we're going to go along the curve here and see what is happening to our x value. While we are going up like that, our x value is going in that direction. Therefore, we are going to the left, we are getting smaller values down there. So, as the value of x is increasing, going up, the point on the x-axis is moving more and more to the left, which is decreasing and is getting less. The values of x in the n-variable region may be satisfied by the set of x such that x is less than negative 5 over 3, like that. So that is the set of x such that x is less than a negative 5 over 3. So let us take a look at what goes on the other side, right there. Notice that we begin here as we go up above the x-axis, that is where y is equal to 0. So we are going to go for y greater than 0. We are going up like that. So we are traveling along the x-axis to the right. As we go above the x-axis, the region in which y is greater than 0, the point is moving to the right along the x-axis, showing that the values are getting larger all the time. The region is therefore specified by the set of x such that x is greater than a half, and that is what we have right there. The set of x such that x is greater than a half. If the points continue their motion, we will never see them going below the x-axis. Therefore, the inequality y is greater than 0 will be satisfied by all values of x on the left and all values of x on the right. So see, if we continue like that all the way, and if we continue, we realize that as long as we continue on the same path, the curve will never get below the x-axis. Therefore, all values that are less than negative 5 over 3 and all values that are greater than a half are involved. Right. So, all values of x are involved. All of those that are to the right and all of those that are to the left are involved. So, the set that contains all of the elements that belong to the two sets is known as the union of the two sets, and that is the one that we are going to use. So all of the elements will be involved, so the union of both sets will be our answer. The answer may be stated as the set of x such that x is less than negative 5 over 3 union the set of x such that x is greater than a half. We will do well to note and remember that in any single problem, the inequality signs are opposite to each other. Therefore, if we have accurately determined one, we may just write down the other. Also, when the direction of motion of the points are taking them together, the sets will intersect each other. We adjust our answers accordingly. When the points keep going apart, all of the values of x in both sets will form the solution, and the union is the preferred option. So, when we have them going apart, as in the case that we have here, it is always the union that we use. When we have them going together, it is always the intersection that we use. And when we are using the intersection, we may write the information in one set in the format that is given. We are attempting to determine where y is less than 0, that is, where the curve is below the x-axis, and this is given in terms of x. So let us begin where y is equal to 0 by solving the equation. Of course, we need to know where y is equal to 0. And no problem with that trinomial. X is equal to -4 and -3. So place the values on the x-axis. -4 is the greater negative value, or more negative than -3, and is therefore placed to the left of -3. The curve is U-shaped because the x-squared coefficient is positive, and the curve will pass through the x-intercepts that are given right there in that diagram. So that we have. Now, let us put the points in their respective places and traverse the portion of the curve that is below. So less than 0 means below the x-axis. While the curve is going below the x-axis, what is happening to the values of x? So while the curve is going below the x-axis, look at what is happening to the value of x. Curve going below, and the x values are going together. So while the curve is going below, the x values are going together. And remember our format for that one? The points move in a direction towards each other, as in our first exercise. The solution will have the format x such that -4 is less than or equal to x is less than or equal to -3. And of course, that is the one that gives the intersection. The smaller number is encountered first in the expression. So when we are putting the information like this, we have to put the smallest one down here. So the smaller one goes first. -4 is less than x is less than -3. We are attempting to determine where y is less than 0, that is, where the curve is below the x-axis, and this is given in terms of x. So let us begin where y is equal to 0 by solving the equation. So we are going to solve that equation, and what we have done is that we have multiplied through the entire equation by a -1, or we may say that we have divided through the entire equation by -1. How do we do that? The mechanics of it is that we change all of the signs. And of course, we have our simple trinomial that factorizes quite easily, and the 2 points are x is equal to 2 and x is equal to -4, although the value of 4, if we are just to look at the size, is larger because it is a -4. It is very much less than +2, so that number, -4, is placed to the left, like so. Remember that a curve that has a negative x-squared coefficient is umbrella shaped. So this is what we have here, negative x-squared coefficient, so the curve is umbrella shaped. There we have our umbrella shaped curve that passes through -4 and 2. And what are we going to say? Is less than 0. So what do we mean? Put the points in their respective places and move along the part of the curve that is below the x-axis. Yes, we have it right here, less than 0. So we are going to go below the x-axis. So while we are going below the x-axis, notice the motion along the x-axis. So, what is the motion along the x-axis? Of course, the points are moving apart in such a way that they are further apart all the time. No intersection here. The statement will contain the union of the sets. Of course, we will not have an intersection. Therefore, we will use the union. We are using the union because as we continue along that same path, there will never be a time when the curve will go above the x-axis. So that is going to be true. The statements are going to be true for all values of x. Therefore, the set that contains all the elements of the two sets is going to be the union of the two sets. So, of course, if we are at this point, we are going in that direction, means we are going less than -4. So we have right here the set of x such that x is less than -4. If we are at this point, we are going in that direction, greater than 2. So we are saying that the set of x such that x is greater than 2. We are attempting to determine where y is greater than or equal to 0, that is, where the curve is above the x-axis, and this is given in terms of x. So let us begin where y is equal to 0 by solving the equation as usual. And of course, we have negative, positive, negative, and we are doing our little mechanics, either multiplying or dividing by a -1, and the result is that all of the signs of all of the terms will be changed to the opposite one. And of course, solving this gives x is equal to 2 or 5/2. Of course, 5 divided by 2 is 2.5 or 2.5, so 2.5 is greater than 2, so we'll have that 5/2 to the right. So place the roots of the equation on the x-axis, right there, and the curve has a negative x-squared coefficient, that is, it is umbrella shaped, and it passes through x is equal to 2 and x is equal to 5/2. Like that. Greater than now, the points will move in order to be above the x-axis. We will also take note of the corresponding movement along the x-axis. So we are going to move along the curve, and we are going to see what the movement along the x-axis is. Of course, above, we are going above, and the values of x are getting closer and closer together. So we are looking at an intersection of the two sets. And of course, that solution may also be written in a single set. So the points are moving closer to each other and will eventually intersect. The form of the answer should indicate this fact. So it is the set of x such that 2 is less than or equal to x is less than or equal to 5/2. And of course, we know that we could have written that with the intersections of the sets. Sometimes we are required to solve a quadratic inequality in which the right-hand side is not equal to 0. In addition to that, we are required to solve it graphically. So we are solving it graphically, and the right-hand side is not equal to 0. In that particular case, the right-hand side is equal to -5.5, -5.5. Remember that the solution requires the values of x for which y is less than -5.5. What do we mean when we say less than 5.5? Well, when the right-hand side is equal to 0, the x-axis is used as our reference because y is equal to 0 on that line. As a matter of fact, y is equal to 0 is the equation of the x-axis. That line. the right hand side is equal to negative 5.5 and y is equal to negative 5.5 becomes our new line of reference. That is our line. Y is equal to negative 5.5. Remember that y is equal to a constant is a line that is parallel to the x-axis and crosses the y-axis at negative 5.5. These lines you will see again in linear programming or similar lines in linear programming, and we have seen lines that are similar to this in equation of a straight line and straight line graphs. Let us draw the curve whose equation is given. So the curve that the equation is given is which curve? Let us go right back. The curve equation is given is this one. X squared minus 2x minus 8. That's the curve. And the curve on the axis looks like this. Under examination conditions, candidates are usually required to draw the curve for themselves, and usually before the section that requires the solution of the quadratic inequality. So we draw the curve first, then you go to the next section and they say solve the quadratic inequality. We know from earlier in the lesson that the region spoken about is below the line y is equal to 5.5. Our points of reference will be the 2 points where the curve crosses the line y is equal to negative 5.5. So we have those 2 points, and the solution is given in terms of x. So we are interested in the corresponding x values. One right there at negative 1, the other one right there at positive 3. So they are x is equal to negative 1 and x is equal to positive 3. In order to go below the line y is equal to 5.5, the points will move towards each other as in the case of the intersecting sets. Now we are talking about these 2 points, and we are talking about the points on the curve that are below the x-axis. So if we go below the x-axis, we are going in this direction. On the x-axis, we are going in that direction. And if we are going below from this point, we are going in that direction. And along the x-axis, we are going in that direction. Like that. And we know when we come together like that, the solution will be the set of x such that negative 1 is less than x is less than 3. If there is only one thing that is obvious from the presentation of this lesson, it should be the need to rely on previous knowledge. Some of the topics that played an important role are sketching parabolas, equation of a straight line, solution of quadratic equation, just to name a few. If this is an object lesson to go by, there will be other topics that will make use of knowledge that were communicated in this one. Do not be afraid to make use of previous knowledge, and taking steps to ensure that the principles are all understood is very important, because one will never be able to tell when such knowledge will be required again.